Hello everyone, welcome to my project Genie, where I will walk you through how I use generative AI to turn unstructured environmental emission data like PDF reports into an interactive, explainable, intelligent map-based system. This isn't just a data visualization project. It's an AI pipeline that brings together document understanding, semantic matching, geospatial plotting, and even image language reasoning. Let me set the scene. Uh, Environmental emission data is crucial, but it is often scattered across governmental reports, sustainable disclosures, or scanned PDFs. These documents usually have tables, sometimes merge cells, non-standard formats, or messy layouts. Even if you do manage to extract their numbers, you often left with the vague city names and with no geographical coordinates. So we have three problems. The data the data is unstructured, location are ambiguous, and these insights are hard to communicate, especially visually. The solution that I built uh, to tackle this problem, I built an four-step AI system that automates the entire process from document to insights. Extract structured data from PDFs using Gemini, match city names to real-life coordinates using FAISS FAISS and Sentence Transformer, and create an interactive map using Folium. Interpret the map using OpenCLIP model, which is a vision language model. And first, by installing the dependencies, uh, which will be used in these projects, and importing those libraries. First, we'll authenticate the API using API key, which will be found at Google AI Studio to authenticate the Google Gemini to Flash. And we will create an helper function which sees whether there are too many requests or the service is available using these codes 429 and 503. In the second line of this function, which helps the model to retry again when the output is not desired. The output is not desired. And loading the secrets. We will add the yeah, our API key here and by name Google API key, and we'll paste the API key here. And next we will generate a test response um, using this code format, and we'll be using the our model Gemini 2.4 Flash, and like the prompt is like what is today's test. This implies that the today uh, this output says that the knowledge cut off with the outside world, which means the after this date the data is not present with after this date the data is not present to the model. And going on to the next step, we'll be loading our emission report uh, using LangChain's PY PDF loader. uh, it is an emission report consists of Indian cities with CO2 emissions, and we'll load this PDF loader.load where all pages will be loaded. And we will do some pre-processing steps to extract the information from these pages, and we will get an extracted information like this, like, and uh, these are like sentences, and now we want to convert these into a structured JSON format, which helps to get an tabular data from these sentences. Generally, an Gemini model or any other GPTs will give an fuzzy output which will depend on the input, and it will change every time. To get a structured output, we will define a class with named emission report, and we need these four keys in this JSON format, and we will uh, tried this emission reporting response schema where we in config of this model where we will configure these all these things, and where temperature is zero point 0.1, which gives that the output will not change, not give any creative outputs or not. It will ensure that. And now we have converted these all these uh, emission report lines into structured JSON, where we can see the outputs in this follow this follows. And we'll now convert these JSONs into CSV by using by using pandas. And the shape of this data frame is 100 cross 4. And now which where in this data frame we will see some unique locations. These are some unique locations which are present in that emission report. And now we want to plot these in the map. We can plot this using Folium. And to plot, we need longitude and longitude of that respective city. To get the longitude and longitude of the respective city, we have a data set named cities 500 from geo names, where we will get where they have many cities with population greater than 500, uh, with entries of 1,85,000. I'll be writing my path of these geonames dataset and some pre-processing steps to get the desired data frame. And now we'll be creating embeddings. We will be using embeddings here because for semantic search of the city names. Sometimes city names will be like Bombay and Bombay for Mumbai, and sometimes New York YNC. So we will search those names semantically so we can get the correct city names, longitude and latitude, uh, as mentioned in the emission report. We will be using a sentence transformer, which is all many L6 version 2, where we will encode this everything. And now to index the above embeddings, we will use a FASS, which is a Facebook KI similarity search library used for efficient similar search and clustering of dense vectors. Where we have turned the above documents into embeddings, like city names and these embeddings. Now we will store them in the FASS index, and you can ask us like, which stored vectors are closest to the new ones, and it returns the top matches like recommendation engines or semantic search. And we will be using index flat L2, which will use L2 distance, which is Euclidean distance. And the shape of our embeddings is like this shape, which is an Hughes embedding. So we are unable to plot this data. And next, we will using this index flat L2, which is an L2 distance, like means Euclidean distance. And now we will store these in store in a database, and next we will see whether this data is correctly stored or not, and these many vectors are stored successfully. And now we will use an retrieval function to retrieve the city names as required. Suppose we will give a city name using this unique city list where we have unique cities, and we will search using it, and by search city and q, which is an very like city name. Each city name is going to be a q, and we will get the coordinates, and we will make a dictionary of that. We have these many city names, and now we will be creating a data set for that, like data which contains the city name and its coordinates. And now we will zoom India at first because the city emission report is of India, and we will zoom at Indian place in Folium. And now these are helper functions which will be how you can now you can see that they successfully plotted these emission reports, and we can verify like which these are the correct emission with this. And this in HTML format. To further process, like in using image understanding, we need a screenshot of this. So we will be using Selenium for the screenshot, and we'll use drive Chrome web driver, and we have taken a screenshot like this. Save screenshot. And next we will see like how the screenshot, and we will send these image into an OpenCLIP image reasoning model, which is an vision transformer. It is an image encoder and masked self-attention. Uh, it is already trained on massive data sets and then basic image of this, and we have converted into tokenizers and basic, and we will see the image way, what is that image, and this, and now we will get the interpretation is like this is an emission report with some confidence score like 0.99, which says that the above is an emission report. And for like detailed description we can ask the model to give like what is this and etc etc. And now we will go into the LangChain agent. Now first we will we'll create and test the agent to see whether it is working or not. Now first this is the brain of the agent, like this model and everything. And now first we'll create two tools like calculate area and climate tip, and we will use memory so that it stores the history of previous charts. Now we will run the agent by giving agent.run. Give me the tip for the climate, then calculate the area of the circle with radius 6. Now first it will give like climate tip, like reduce reviews and everything. And next, do I need to for the first answer, and next we will calculate the area with radius 6, and it will calculate, and the area is like square. We have got the correct answer. As I told, this is the brain. Now we will use the LLM where we have seen the agent is working perfectly fine. How to create for our original data and stuff. Now first we'll be load our brain of the agent, and next we'll create some tools. Like first we will get emission by city. Like it will give, it will know if they know by city name, we will get the emission. And next, coordinates, like if we give the city name, and we will get the coordinates of that city. And next, the internet, like it will use that OpenCLIP model, and we will get the correct emission there. And next we'll use like search city like above. And now all these are tools, so we are keeping in a list. Now we have no like conversation buffer memory used to store the memory of the previous charts. And now we will be initializing our agent by the function initialize agent, and we have used the four tools and brain of the LLM Gemini 2.4 Flash. And the memory is conversation buffer memory. And next, this is a rag response by the above. Mm, we have got like what is the CO2 emission in New York. As you know, the rag will give like what is present in the emission report only. Like as New York is not present in the emission report, we are getting no emission data was found for New York, and afterwards for Korba, which is there in the emission report. So we have got the correct emission report, and afterwards we can use agent.run, and this is another step. like agent button, where will interpret the emission map and tell me where is the curve and its emission stats. Like it will give the correct longitude and longitude of the curve and the emission report of the curve, where it uses the several tools like city coordinate tool, emission fact tool, and etc. And now to use these results in an interface, I have used Gradio for this, where I will interact with agent using chart, like this creates a chart interface, and next creates the UI with the avatar images like these two images. Now we can see like we will do demo nodes as it is as demo, get it demo. And now we have this chart interface with these avatar images and I have just the basic hello and next we will type this what is CO2 emission of oil like it is taking some time and it's given the correct output as present in the emission report and this is an yeah this gives because the verbose is true here you can see like in agent verbose is true this gives the output so that we can understand what is happening with an agent and now getting on to the final details like why this project matters. This approach bridges the gap between data locked in documents and actionable climate intelligence in those instead of spending days parsing PDFs and manually mapping cities. You can go to upload and insights in minutes. It is scalable, explainable, and intensive, perfect for researchers, NGOs, and government analysts working with environmental data. Limitations to keep in mind. It is not perfect. Like Gemini may not able to parse like extremely complex tables, etc. And sometimes in few cases may not give correct similarity search and clip OpenCLIP is isn't fine-tuned with emission maps, so it is not the description may not be generic. As of future possibilities, like we are planning to integrate like live sensors or satellite data for real-time emission tracking and using and domain-specific language models for precise map summaries and building in chatbot layering where users can ask questions like which cities have highest per capita emission last year, like etc. And thanks to the Kaggle team for this competition and these scores which I have liked. And thank you for my team members who helped me in this project. And these are the sources. Thank you for